Welcome. This video breaks down the technical architecture of the RSHL Terrarium kernel and the Aletheius Sovereign Substrate. This is a distributed, hardware-aware, and cryptographically secured machine learning inference and consensus network. It is composed of four primary layers: the RSHL Stability Kernel, the RSHL Mixture of Experts Transformer, the Terrarium Edge Evolution System, and the Fortress Trusted Execution Environment paired with HotStuff Byzantine fault-tolerant consensus. Let's go through each one. At the foundation is the RSHL kernel, implemented in Python using NumPy and SciPy. It defines the Rivers metric, a custom Riemannian-style metric tensor computed as the identity matrix plus epsilon times the outer product of the identity gradient with itself. This metric governs the geometry of the state space. The kernel then continuously evaluates the spectral radius of the system's dynamics matrix, specifically the maximum real eigenvalue lambda max. When lambda max is negative, the system is stable. The kernel also runs noise dampening cycles, injecting perturbations and monitoring whether the system returns to equilibrium through exponential decay. The RSHL Mixture of Experts Transformer, versions 7.2 and 8.0, is the core inference engine. A gating network routes each input token to the most relevant expert feedforward networks in parallel. Three key engineering choices define its performance. First, direct CuBLAS calls eliminate Python overhead, maximizing GPU throughput. Second, fully sharded data parallelism, or FSDP, enables memory-efficient training and inference at scale. Third, grouped query attention provides constant time, O of 1 key-value cache management, critical for long-context inference. Terrarium Edge Evolution version 4.0 handles deployment on resource-constrained edge hardware. Each node runs an 8 billion parameter model with INT8 and INT4 quantization to minimize memory footprint. Low-rank adaptation, or LoRA, layers enable continuous on-device model evolution without full retraining. A geodesic state space model provides temporal reasoning. The ThermalGovernor enforces hardware safety, throttling at 85 degrees Celsius and triggering emergency protocols at 90. All internode communication happens over an authenticated peer-to-peer mesh using HMAC signed messages over UDP and TCP. The Fortress Trusted Execution Environment node partitions inference across two hardware security domains. Query, key, and value computations execute inside an Intel SGX enclave managed by Gramine, providing CPU-side confidential computing. Feedforward network execution runs on an H100 GPU with confidential computing mode enabled. A cross-layer attestation chain cryptographically verifies the integrity of every computation across both domains. The proof of useful work verifier validates each inference task via cryptographic nonce challenges. LoRA weights are stored in a content-addressed registry, ensuring tamper-evident model versioning. Decentralized state agreement is achieved through a chained HotStuff Byzantine fault-tolerant consensus protocol, implemented in Rust. The protocol proceeds in 5 phases: propose, prepare, pre-commit, commit, and decide. A leader node broadcasts a proposed block containing the view number, height, parent hash, transactions, and a justifying quorum certificate. Nodes vote using SEC 256K1 ECDSA signatures. A quorum certificate is formed when 2/3 plus 1 of nodes agree, guaranteeing safety even under Byzantine faults. Transaction types include revenue splits, penalties, and rewards, enabling on-chain economic coordination. To summarize, the Aletheius Sovereign Substrate is a 4-layer system. The RSHL Stability Kernel provides continuous mathematical stability monitoring via the Rivers metric and spectral analysis. The RSHL Mixture of Experts Transformer delivers high-performance inference using CuBLAS, FSDP, and grouped query attention. Terrarium Edge Evolution version 4.0 enables distributed, hardware-aware, thermally governed edge inference with on-device LoRA adaptation. And the Fortress TE combined with HotStuff BFT delivers cryptographically attested, Byzantine fault-tolerant, decentralized consensus. Together, these layers form a persistent, secure, and autonomous distributed inference network.